Hello everyone, great to see you all here. I'm Arjun. I'm heading engineering and research for AI security in Cisco. Today I'm going to talk about our journey from Postgres to CockroachDB, just like perhaps Gavin did just before me. And I'm also talk about how our acquisition to Cisco a couple of years back helped accelerate the journey to CockroachDB as well. A bit of a background, so Armorblocks was an email security company. We used large language models to detect different kinds of email-based threats like phishing attacks, business email compromise, account takeovers, to name a few. I was one of the founders, chief architect in Armorblocks. And my expertise is to apply AI and ML for cybersecurity problems. I'm by no means a database expert. The same goes for the rest of the Armorblocks team as well. So our learnings to scale and operate databases was rather an extremely painful one, right? And Cisco acquired us a couple of years back in 2023, and post-acquisition, so Cisco leadership requested us to expand beyond email security, and our focus became AI products. Today we are responsible for building all AI products in Cisco. There are three main ones: AI Defense, Canvas, and Assistance. AI Defense is an AI security product. If you're building AI applications, agents, MCP, large language models, you can use this product to go secure your AI application. Canvas is also focused on AI. It's an AI orchestrator generative UI interface. It interconnects with all Cisco products, primarily focusing on networking operations and simplifying network troubleshooting using AI. And Assistance is a platform for building AI assistants for all Cisco products. Okay. A bit more context, in Armorblocks, before the acquisition, we're protecting close to 2 million plus mailboxes, 10,000 plus tenants. And during peak hours, we are processing close to 25,000 emails per second. And 50% of the workloads came from enterprises, and the remaining 50% came from managed service providers, right? But the number of tenants, as you can imagine, were lopsided towards the number of MSSPs as opposed to enterprises. One of the biggest bottlenecks back in 2022 for us was not our models, it was not our GPUs, it was database, right? So we were based in Cupertino, and in 2022, for a few months, we all used to wake up at 5 a.m. every single day just to make sure our databases were up and running, because our customers were all in the East Coast, and they come in, log into work, right? And the email traffic starts to spike up around 7 to 8 a.m. and then it tapers down around 2 to 3 p.m. So during that window, we had to make sure our database is up and running, pretty much keeping the lights on for us. This was a nightmare because instead of focusing on our core business, which is email security, and making advancements there, a big chunk of our team was focused on how to keep our databases up and running. And this included our head of data science, our head of UI. All of us were focused on how to keep this database working, scale for the workloads. I'll walk you through our journey of how this whole thing started and our key learnings along the way. Back in 2018, we are a stealth startup, right? And we are still building the product. And we decided to use Kubernetes-based microservices architecture. And we also decided to run our database in Kubernetes. Hindsight, it's a big problem. I'll talk about it. It was a typical Patroni-based deployment, one primary, couple of backups. We used Patroni's Kubernetes operator. And operators back then was not a lot more mature, right? So we had to do a lot of customizations to keep the operator function for us. We had about 25 customers, things were running fine, we had no issues with it, except for a few glitches here and there where the database is used to fail over. And we didn't notice it, we didn't think it's a huge problem. So a couple of years went by, things were awesome, right? Fast forward to 2020, we became a Series A startup, right? We are growing, we had SLAs with our customers. And these pod failover, the Postgres failover glitches started to become a lot more prominent, right? The customers started to notice them. And these things got escalated to incidents and outages. There are three main reasons, or quite a few reasons why Kubernetes decides to fail our pods, and there are three main patterns that we noticed. It could be because of high resource usage of database, or databases were hitting the resource limits that we said. We also have the noisy neighbor problem. Kubernetes sometimes can schedule non-Postgres workloads in the same node as Postgres, and if a different pod uses a lot more resources, it decides to evict them and put them in a different node. We also had issues with underlying Kubernetes node instability. The node by itself could be unstable, and sometimes nodes go through an upgrade that results in pods being evicted, right? Essentially, what we noticed was anytime if there's a failover from primary to a backup, right, a pod fails over, it takes a few seconds to a few minutes for the standby to become primary. And in some cases, both the standby and the primary fail over at the same time. And at this point, we had extended hours of outage, and because there is no quorum left to elect a leader. And we were trying to solve these problems, by doing some complex DevOps work. So we introduced taints, tolerations, node affinity, pod anti-affinity to make sure, Postgres nodes are the only Postgres pods are the only pods running in a Kubernetes node, right? And no other worker pods can be scheduled in the same node, right? So that's what we did. And this solved for noisy neighbor problem. This also solved for the resource usage issues. But the resource limits, were still a problem for us. We went and actually, removed the resource limits from the Helm charts, and things were fine. To alleviate for node instability issues, what we did was we went with multi-zone deployments. We introduced node maintenance windows so that upgrades happen within a specific window, so we can control node instability problems. We also enabled huge page tables, extended the file descriptors in the underlying Kubernetes node, so databases did not cause any kind of instability to the node's performance itself. What this meant was our upgrades became extremely complex. Our DevOps workflows become super complex, and we kind of regressed from our blue-green deployments. So if you think about it, essentially what we're doing was we're trying extremely hard to run Postgres in Kubernetes just like how we were running it in a virtual machine. We were why are we doing this whole complex business operations? Let's just move Postgres deployment to virtual machines as opposed to running in Kubernetes. That's one of the biggest learnings for us, right? So it was Kubernetes or Postgres is not built for running in Kubernetes. That was the key takeaway that we took for ourselves. Maybe this was 5 years ago. Maybe things have changed so far. Right? Maybe there are better Kubernetes operators out there, database operators out there for Postgres that can solve for this problem, but still, to me, it kind of defeats the purpose for why someone wants to run a database in Kubernetes. So this was our architecture back in 2020, right? So Postgres was running in virtual machines, a typical Patroni-based architecture, very similar to how we were running it in Kubernetes. We had one primary, couple of standbys, we had load balancer, we had PG bouncer. We had enabled sync standbys for streaming replications. We have PG backers for backup and recovery. Around 2021, we grew to be a Series B company. We raised more capital. We grew our GTM team. It meant we are bringing more and more customers. It meant our workloads were also increasing. We also had a very interesting contract with MSP, and they brought in about 1 million mailboxes overnight, which meant our workloads kind of tripled in an extremely short amount of time. So to sustain this growth, what we started doing was we started to upgrade our 3-node cluster to a 5-node cluster, and we started to beef up our node size to the maximum possible in GPU because we started to see vertical limits of Postgres itself. Primary was configured only to do writes, and then we moved all the reads to standby, so because we had some room to grow for the primary, right? Sync standbys had extremely complex. Under heavy workloads, sync standbys was performing poorly, and then we upgraded our sync standbys to async standbys. We kind of took the risk of data loss, especially if a primary is failing over. And then we also started to engage with database experts because we're trying to look for a long-term solution. And we also brought in Percona. Percona was one of the database management consultants because we're not database experts, 3 years in the company. And they were monitoring the database 24/7, giving it all the love and care it needs so that database is up and running. 3 main challenges still remain, right? So it was moving forward a year. First one is vertical scaling. I know Gavin talked about vertical scaling. We started to see the limits of vertical scaling. I'm sure you all know, Postgres was built for vertical scaling, not for horizontal scaling. There is no native active deployment in Postgres, right? Any active solution in Postgres looks extremely complex to us, and this was one of the biggest learning for us. Then we also had this self-imposed problem of multi-tenant schemas, right? Because we are a security product, we are using emails. Our customers used to ask us, hey, how are you storing this data? For how long are you storing this data? They were extremely sensitive to how we store this data. So back then we started to create a separate schema for each of the tenants, right? And this became a problem as we started to grow, right? So adding more and more tenants, once we started to hit tens and thousands of tenants, the number of tables that we had became extremely huge. Then we started to see new kinds of scale issues. Transaction IDs, we started learning about what is a transaction ID in Postgres. We started learning about what is vacuuming. Pretty much transaction IDs, if it wraps around, database freezes, that's what I've been told. And we had an interesting call with Percona back in the day. And one of the engineers in Percona, he mentioned, your database is going to freeze in a couple of days, and if you don't act on it, you're going to have a huge outage. It's going to take possibly weeks to recover the database. And that's when we started to learn about transaction IDs and how do you prevent transaction IDs, right? Pretty much we had to go and vacuum the tables on a constant basis to make sure the transaction IDs don't wrap around. Because the number of tables that we had were close to north of 250,000 to 500,000, the default auto vacuum jobs that comes with Postgres was not enough to keep up with the transaction ID wraparounds. So what we started to do was we put in a small team that was building custom vacuuming jobs that was running outside of Postgres to make sure we don't run out of transaction IDs. And we had issues with backup and restoration as well. We used PG backrest. We're running into issues with missing wall files, replication lags, and if the standby is has a huge lag, we had to go and re-init the standbys to make sure it can catch us up. But anytime we started to re-init it started taking days because the volume of data we used to store in the databases became so huge. So then we were the business is growing. Our GTM team was extremely concerned, not because of our threat detections, not because of our models, because how are we going to fix our databases? So because we raised more capital, we are let's start throwing more money at this problem. So what we did was we created multiple database clusters, and we started to separate them by tenants. Essentially, what we did was sharding by tenant level as opposed to sharding at a database or table level, right? This was fine, but we kind of incurred an extra operational overhead of managing multiple database clusters, and we also started to take a hit on the margins, but database was not a bottleneck anymore, right? So which was okay. Around 2023, we started engaging in a conversation with Cisco for potential acquisition. And the biggest concern for us was when we go into Cisco, scale is going to be extremely important because we got to operate at a Cisco scale, right? So, and we started to seriously think about what's the long-term and permanent solution is going to look like. And that's when we started to look for potential alternatives and solutions that's built on 4 simple first principles. Is the solution truly distributed, is geographically distributed SQL store? And do we have an option for a managed instance as opposed to a self-hosted instance? And have minimal operational overhead, right? So no transaction ID issues, no vacuuming, built-in recovery and backup systems, active should be built in, simple and easy to scale. And also look for the people. Are the people behind these solutions and products, can we trust them? Can we work with them? They support us and help us when we run into problems, right? And or better yet, guide us before we run into problems. So we did based on these 4 key principles and criteria, we started to do a POC with a whole bunch of solutions. Obviously I'm here, right? So we picked CockroachDB. So that's our high-level journey, for the last 5 years from 2018 to 2023, from Postgres to CockroachDB. So today in Cisco, how are we using CockroachDB for Cisco AI specifically, right? We talked about 3 products in Cisco AI: Defense, Canvas, and Assistance. All 3 products use CockroachDB. It's built natively on top of CockroachDB. Here's a very simple high-level architecture diagram for how things work. Pretty much we are looking at the traffic between application to large language models across all these different products. We store the prompts from the applications and the prompt response from the large language models, and we store them in CockroachDB. We maintain the entire conversation history across all thousands of Cisco customers in CockroachDB. We have also enabled CDC between CockroachDB and Snowflake. Snowflake is what we use for our retraining pipeline for our safety and security models for the AI Defense product. And we have Databricks, change data capture enabled Databricks. And Databricks is the pipeline for us to go retrain the models for Canvas and Assistant products. There is historical reasons why we picked Snowflake and Databricks, because we acquired another company called Robust Intelligence, and they were using Snowflake for threat detections. We kind of kept it with that. We also have deployed CockroachDB across 6 regions globally. And one important thing we kind of forgot to mention was we kind of moved away from multi-tenant schemas, schemas per tenant, to multi-tenant tables, right? So that's one of the things that we did along this journey of migrating from Postgres to CockroachDB. Because CockroachDB, when you started talking to the team, they kind of mentioned the number of tables you can actually have in CockroachDB, it cannot be in hundreds of thousands, it can only be in thousands. And we realized our architecture for multi-tenant schemas doesn't make sense anymore, and multi-tenant tables works extremely well. I think that's pretty much it. We are extremely happy with CockroachDB today. and so far no issues. Our focus is primarily on building products for our customers, solving the problems for our customers, as opposed to building and maintaining databases, right? So databases is behind the scenes. We don't even talk about it that much, except for the time I spent preparing these slides and for this conversation, which is pretty good, a testament to how CockroachDB is working well for us. Yeah, thank you.